Okay, so chapter 7, pure 4 vectors. So I have uploaded quite a few resources, some PowerPoints, which are basically just revision, really, of GCSE or IGCSE. But I think you might find them sort of like useful to refresh your memory. And also you might like to try some of the questions. They're not very dissimilar from what you're getting in the exercise on this chapter, which is here on the next page. They're very, very similar. So I strongly recommend that you have a look through and have a go at exercise 7A. So just going to talk our way through. So 7A, so basically it's on, there are quite a few questions to do, and everything is really explained on the PowerPoints and the resources that I've also uploaded for you. But let's have just a look through just to make sure that everybody is, just to give you a bit of a start really. So a vector has both magnitude and direction. So for example, if you have vector A, the magnitude is basically how long its size, okay? And its direction, well, basically, if I wrote this as being A, that wouldn't be correct because it's not going in the same direction. But A written like this, now maybe a little bit longer, but anyway, you can see that the position where it is doesn't matter. What matters is it's always got to have the same length, in other words, magnitude, and the same direction. So that's what we mean by magnitude and direction. Okay, so I'm going to get rid of that one then now, because we'll probably not use that one again now. Okay, so the direction of the arrow, so as I just wrote, the direction of the arrow, so PQ, right? If PQ was, say, A here, if PQ was A, then QP would be minus A because it's going against the direction of the arrow. So when you've got vectors questions and you're doing diagrams and things like that, you must always remember to put the direction on the diagram. So for example, here, you've got A and minus A. AB and BA are the negatives of each other. And that's the same even if they're column vectors. So if you had something like 2, 3, okay, then the negative it would be minus 2, minus 3. Okay. And also you can see that parallel vectors is of quite important, is something that's quite important you've got to be on the lookout for. So parallel vectors means they have obviously the same direction. So for example, this one could be A, this one could be 2A, but they're parallel because one vector is a multiple of the other. A and 2A, okay, the direction is not affected. The length, the magnitude is the only thing that's affected, okay? Let's just pause that a moment and move on. So we're looking at this diagram here now, which I've drawn on here. So we know that AB, the vector AB, is equal to A, and we know the vector BC is equal to, actually that should be a B, but we don't know AC. What is AC? We haven't got anything marked on that. The only way we can get from A to C is by going from A to B and then from B to C. we can only go along the paths that have been marked. So that is going to be A plus B. Okay. Now this is what we were talking about a moment ago when I was talking about A and minus A and 2A and everything. So if we're looking at this section here now, you can multiply a vector by a scalar. A scalar is a quantity. It's just a number, in other words. And it's just a number or a value. So here we've got A, 3A, half A. So if you've got A, 3A, and we usually put a little wavy line underneath, or a half A. Here, lambda, the scalar quantity, is 3. And here, lambda is a half. So lambda, the scalar in vectors, is denoted usually by the symbol lambda, the Greek letter lambda, okay? And it's the same as, so for example, if I had this one here, minus 2A, this time lambda is minus 2. And if lambda is negative, it just means that the direction has changed to the opposite direction, as it says here. Okay, so basically, we're just going to talk our way through this, just in case you prefer listening rather than trying to read it yourself. So we've got this diagram here. I know it's not a very good diagram, but anyway. Now you can see that the letters, the lowercase letters are the vectors, and they're also denoted by a squiggly line underneath, because they're written in bold in the textbook, but when you write them down, you write squiggly lines, but they tend to get a little less squiggly as you go on. But anyway, so what you've got to do is you've got to use the information on the diagram to get from each of these points, say, from P to S. Now, if you went from P to S, now it always helps to write down the paths that you're taking. You're going from P to Q, and then Q to S. My P to Q is A, and Q to S is C. So that's it. So because it's the question's asking us to write them in terms of A, B, C, and D. So we've got to use the A, B, C, and D letters. So RP then. So let's see. So how would we get from R to P? Well, we'd go from R to Q. We can't go, there's no point in going from R to T, because then we couldn't get from T to P, because there's no vector marked on there. So we have to go from R to Q, and then from Q to P. So R to Q is going to be minus B, plus QP is going to be A. Now you can just leave it like that, but if you want to get rid of that leading negative, you can put the positive thing first. Okay, right, P to T. So P to T is P to Q plus Q to R. We can't go directly from P to T. We have no vectors, we have no information about how to get there. So we're going P, Q, QR, and RT. So P to Q, watch out for the negatives. QR is plus B, and RT is plus D. So we could put the two positives there in front like they have, but if you did that in an exam, that would be just as good. Okay, it's just how we prefer things to look without the negatives. Things starting off with negatives, that's all it is. So TS then. So we're going to go, to get from T to S, we can't go TP and PS. So we've got to go TR plus RQ, and then we'll go from Q to S. So TR is minus D. RQ is minus B. And QS is plus C. So C minus B minus D, all nicely in alphabetical order. Okay? Now, this is example 3 on page 100 now. Here, you're told that this is a parallelogram. Now remember, for vectors, being parallel is an important property. In a parallelogram, or in this parallelogram, AD is parallel to BC. Also, AD has the same magnitude. Oops, that's not very good, as BC. So therefore, if AD is B, BC is B as well. And if AB is A, DC is A as well. Note that the vertices are in capital letters. Look at the textbook if you find my writing a little difficult to follow. The vertices are in capital letters, but the actual sides are in lowercase letters. Okay, now because it's a parallelogram, this is very important because that's telling you that DC and AB are the same vectors. They're both A. Okay, now you've got to find AC. So AC, so you're going to go from A to D and D to C. Now A to D is B, check which direction you're going in, and D to C is A. Well, you could write that in alphabetical order, A plus B, but you wouldn't get marks lost in an exam if you did do that, okay? Now, often, this is not in the book, but I'm sure you'll come across it, and it's a good example to make sure that you're keeping in mind that you've got to have, for vectors to be equal, have the same magnitude and direction. Where they are, the position of them doesn't matter. So here, for example, a regular hexagon, right? Now, we know that if this is regular, it's literally, if this was called A and this was called B, right? A regular hexagon is constructed of equilateral triangles. All right, so say for example, I'm just making this up as I go along now. So say this is C, okay? Now, because this is A, this is going to be A. Because this is C, this would be C. And because this FA is B, CD is also going to be B. From the center here, across here, that would be A. So FC is 2A. Okay. FC is going to be FA plus AB plus BC, which is just going to be B plus A. That's not very good, is it? But anyway, I'm sure you get the picture. So watch out for those because they can sometimes catch you B plus A plus C. And you could write that A plus B plus C. So if this is C as well, because it's got the same magnitude and the same direction. Now example 4 then, it says to show that the vectors 6A plus 8B plus and 9A plus 12B are parallel. Now that means that one is a multiple of the other, remember? So how can we show that? Well, we have to show that lambda is the same for the A's and the B's, if you like. So you've got, say, compare, you've got 6A and 9A, okay? Well, you can do 9 over 6, which is 3 over 2. And we've got 8b and 12b. And 12 over 8 is 3 over 2. So lambda is 3 over 2. So therefore, we could say that 9a plus 12b is 3 over 2, 1.5 times, if you like, 6a plus 8b.